So we are going to start with the parallelogram law of vector addition. We are handling the parallelogram law of vector addition certain special cases. The formula for parallelogram law of vector addition is this is P, this is Q, these two vectors are tail to tail joined, and this vector represents P plus Q, which is the diagonal of the parallelogram drawn from this point, that is the point where the two vectors join, to the other point. That diagonal represents R is equal to P plus Q. And R is equal to root of P square plus Q square plus 2PQ cos theta. R is equal to root of P square plus Q square plus 2PQ cos theta is the formula for the resultant, magnitude of resultant. The direction, that is the direction of the resultant, that is the diagonal with the vector P, is given by Q sin theta divided by P plus Q cos theta. Therefore, the vector from which we are taking alpha comes in the denominator, and the other vector will come in the numerator. And based on that formula, we will take few cases. They are very important in the examination point of view. When you are given that particular angle theta, then you can use this formula to calculate that. First case is theta is equal to 0. That is, we have one vector in this direction and the other vector in the same direction. That is, the vectors P and Q are parallel and act along the same line. Two vectors which are parallel or anti-parallel, that is acting along the same line, either in the same direction or in the opposite direction, they are called collinear vectors. That is, lying along a line, that is called collinear. Here we consider two vectors P and Q. This is P and Q, which is acting on the same point and having the same direction. It can be a P in this direction, Q in this direction, or it can be a P as a pull and Q as a push. It is easier to visualize P and Q in the form of forces acting on a particle. Vectors can be, displacement can be vectors, velocity can be vectors, but it is easier to visualize in the form of forces. But the same law applies to all vectors, whether it is velocity or force or electric field or gravitational field, whatever vector you consider. For all those, these rules are applicable. R is equal to P square plus Q square plus 2PQ cos 0. Cos 0 is 1, theta is equal to 0, cos 0 is equal to 1. Therefore, R can be written as root of P square plus Q square plus 2PQ. But P square plus Q square plus 2PQ is P plus Q whole square. Therefore, R is equal to P plus Q whole square, square root of that, which is equal to P plus Q. This shows that the resultant of the two parallel vectors is the sum of magnitudes and is directed along the direction of PQ. That is, the resultant is having the direction same as P and Q, and its magnitude is the sum of the magnitudes of the two forces. We can take an example. Two forces, 5 Newton and 7 Newton, act on a particle of mass 6 kilogram as shown in the figure. This is the figure. Find the acceleration of the particle. That means we have to calculate the net force acting on the particle and divide that force by the mass of the particle to obtain the acceleration. Here we have vectors are parallel and therefore the net force acting on them is the sum of the forces. The forces are 5 Newton and 7 Newton and therefore the net force will be equal to 12 Newton acting in the right direction as shown in the figure. Therefore acceleration will be F divided by m, that is 12 divided by 6 equal to 2 meter per second square. Of the second example, we consider 3 forces acting towards right on a particle of mass 5 kg. It produces an acceleration 5 meter per second square. 2 forces are 7 Newton and 8 Newton. Therefore, the acceleration is 5 meter per second square. Mass is 5 kg. Therefore, the net force will be 5 multiplied by 5, that is 25 Newton. 2 forces are 7 Newton and 8 Newton acting in the same direction. Therefore, they too add to produce 15 Newton. And therefore, we have to calculate the third force. That is 7 plus 8 plus the force F, that is we have to calculate. That is equal to 25. Therefore, F is equal to 25 minus 7 plus 8 is 15. Therefore, F is equal to 25 minus 15, that is 10 Newton. Case 2. Theta equal to 180 degree. Forces P and Q act along the same line, that is they are collinear, but in the opposite direction. That is, P is acting towards right and Q is acting towards P is acting towards right, Q is acting towards left. These two are in opposite directions. Therefore, they are collinear, but they are anti-parallel. And what is the formula for finding the resultant of particles which are anti-parallel? Cos 180 degree is cos 180 minus 0. Cos 180 minus theta is minus cos theta, therefore it is minus cos 0. Cos 0 is 1, therefore cos 180 is minus 1. R is equal to p square plus q square plus 2pq cos 180. That is p square plus q square minus 2pq. P square plus q square minus 2pq is p minus q whole square. Therefore, R is the square root of p minus q whole square, which is p minus q. The resultant is the difference between the vectors. One vector is in one direction, other vector is in the opposite direction. Therefore, the resultant will be the difference between these two. And that resultant will be directed along the larger force or larger vector having larger magnitude, that is a larger vector. Usually in P minus Q, we take P as the larger vector and Q as the smaller vector. We usually take P greater than Q. And if P is greater than Q, we have to take P minus Q. And the vector direction will be along the direction of P. We will take an example. 3 forces act on a particle as shown in the figure. Find the resultant force. There is a 20 Newton acting in this direction, a 5 Newton acting towards left, and a 10 Newton acting towards left. This 5 Newton and 10 Newton are in the same direction. Therefore, their resultant will be sum of those two. That is 5 Newton plus 10 Newton. That will be 15 Newton. Therefore, the force towards the left will be 15 Newton and force towards right is given to be 20 Newton. Therefore, net force will be 20 Newton minus 15 Newton, that is 5 Newton. That is along the direction of the 20 Newton force, larger force, which is towards right. Therefore, the net force will be 5 Newton towards right. If mass of the particle is given, we can calculate acceleration. And if somebody asks you what will be the position of the particle starting from rest after a particular time, then you can use S is equal to ut plus half at square to calculate the distance. What will be the velocity of the particle after some time? You can use v is equal to u plus at to calculate the velocity, and this question can appear in various forms. Next example is, that is a bit higher level example. F1 and F2 are two collinear forces acting on a particle. The maximum and minimum net force are 20 Newton and 10 Newton. Therefore, the maximum and minimum are 20 Newton and 10 Newton. When we are adding collinear vectors, say F1 and F2, the maximum value will be F1 plus F2. When two vectors F1 and F2 are combined together, the maximum value will be F1 plus F2. And the minimum value will be F1 minus F2. It is given that the maximum value is 20 Newton, that is F1 plus F2 is 20 Newton, and minimum value is 10 Newton, that is F1 minus F2 is equal to 20 Newton. Therefore, we have F1 plus F2 is equal to 20, F1 minus F2 is equal to 10. There are two unknowns, F1 and F2, and two equations. And therefore, we can solve them and calculate the value of F1 and F2. For solving, we add these two, then F2 will cancel, and 2F1 will be equal to 30, and F1 will be 30 divided by 2, that is 15 Newton, and from this formula 15 plus F2 is equal to 20, therefore F2 is equal to 20 minus 15, that is 5 Newton. We take the case 3. Theta is equal to 90 degree, that is, the two forces are mutually perpendicular like this. One force is in this direction, another force is in this direction. That is P and Q, this is Q, this is P, they are perpendicular to each other, and this R is the resultant. This angle alpha is the angle between P and R. We know the formula for alpha also. Tan alpha will be equal to Q sin theta divided by P plus Q cos theta. R is equal to root of P square plus Q square plus 2PQ cos 90, but cos 90 is equal to 0. Therefore, 2PQ cos theta will become 0. This quantity will become 0. And we can write R is equal to P square plus Q square of the formula. And if P is equal to Q is equal to F, if the forces are equal, then R is equal to root of 2F square, and that is root 2F. Whenever you are given two forces which are equal and mutually perpendicular, you can simply write the resultant as root 2F. We don't need to do any calculation, that will be root 2F. And tan alpha, that is the direction, is given by Q sin 90 divided by P plus Q cos 90. Cos 90 is 0, therefore this term will vanish. Sin 90 is 1, therefore this will become 1. And tan alpha will be equal to Q divided by P. This is a very important law that is applicable in several situations. And that law is, has a name, it is called the tangent law. When two vectors P and Q are perpendicular, the angle made by one of the vectors, that is the vector P, which is given in the denominator, that angle will be equal to, tan of that angle will be equal to Q divided by P. We'll take an example. Two forces 4 Newton and 3 Newton act on a body in mutually perpendicular directions. Find the resultant force. We know the formula for that. R is equal to root of P square plus Q square. P is given to be 4 Newton and Q is given to be 3 Newton. Therefore, R is equal to root of 4 square plus 3 square. That is root of 16 plus 9. That is square root of 25. Therefore, R will be equal to square root of 25. That is 5 Newton. tan alpha is q divided by p, that is 3 by 4. We know that tan 37 degree is 3 by 4. Therefore, alpha is equal to 37 degree. The last case is case 4, that is theta is equal to 120 degree. Cos 120 is minus half. Therefore, P, this is Q. They are inclined at an angle 120 degree. This is 120 degree. And this angle is alpha. That is the angle of the resultant with respect to P. R is equal to root of P square plus Q square plus 2PQ multiplied by minus half. That is P square plus Q square minus PQ. Therefore, if we are given that the two vectors P and Q are inclined at an angle 120 degree, the resultant is obtained by the formula P square plus Q square minus PQ. When these two forces P and Q are equal, that is, we have this P and Q are equal to a force F, then we can write this as P square, that is F square, plus F square minus F square, that will be F square, and square root of F square will be equal to F. Therefore, when equal forces are inclined at 120 degree, the resultant will be equal to the forces, one of the forces. Resultant will be same as the forces. If the two forces, equal forces or equal vectors are inclined at 120 degree, to calculate the resultant we don't need to do anything, that will be same as the value of the vector. And tan alpha is given by this formula, F sin 120 minus divided by F plus F cos 120. Sin 120 is sin 180 minus 60, that is sin 60. It is in the second quadrant, therefore sin is positive, therefore it is root 3 by 2. Therefore tan alpha will be F multiplied by root of 3 by 2 divided by F minus F by 2, when the forces are equal. Otherwise, we have to write this as P into root 3 by 2 divided by P plus Q into minus half. Root 3, tan alpha is equal to root 3. Root 3 tan 60 is root 3, therefore alpha is equal to 60 degree. That is all.